My name is Dana O'Connor from KUNR here at the University of Nevada. I'm here on behalf of the Northern Nevada Science Coalition. Today marks the first of 12 lectures here at UNR sponsored by the Science Coalition, and I have the privilege of talking with our very first lecturer. It's Dr. Lorraine A. Remer. She's from NASA's Goddard Space Flight Center Laboratory for Atmospheres. Welcome.
It's good to be here.
Now, Dr. Remer, I'm not a scientist myself. I'm a person who loves science, is very interested in it, likes to read about it. And I understand a little bit about your work, but can you explain it so that I understand it better and why it's so important to us?
Well, what I do many things, but what I'm mostly involved in is something called remote sensing of aerosols. And that's when we use NASA satellites that receive information of the Earth, take pictures of the Earth, and derive information about that is of scientific interest, or a lot of different types of interest. And my particular specialty is something called atmospheric aerosols. And these are small particles that are suspended in the atmosphere, dust, smoke, things like that.
Now, why is it so important to study these particles?
They do a lot of things. One, we have health issues with these particles. The small particles can get into our lungs and cause problems. We call them PM 2.5. We call them particulate pollution. And there are, EPA is very concerned about this in terms of air quality. But the main reason I'm interested in aerosols is that they do things in the atmosphere that affect climate. And one thing is that they reflect sunlight to space, or they get into clouds and they change cloud properties. And so the fun part for me is trying to understand how it all works, how to put the climate system together. And what I can learn by observing the Earth globally from satellites, something I can't learn by walking around and holding up an instrument as I walk around. So it's fun.
Now, your lecture tonight is entitled, Can Particulates Solve the Global Warming Problem? Can they?
It's an open question. I'm not going to answer that question. If we go about its business as usual, putting particles in the air as we do now, no. The climate is warming. The globe is warming now, even with the particles in it. There are suggestions of enhancing the particulate ability to cool the Earth. And I want to discuss it as an open question, as something to think about. But I'm not proposing it. No one's proposing to do it. It's something we're at the stages of thinking about.
Well, it's good to be talking about it. I'm curious to learn if they can, if particulates can help us with this. And I'm interested to hear people's reactions on the idea of pushing particulates up into the atmosphere.
I'm interested too. Most people's reactions are negative, including most scientists. We don't like to fuss with the natural world. But someone I saw recently, and I can't even tell you who I can this quote to, but it's like, even if you're never going to use a lifeboat, doesn't it make sense to look at it before you need it? And that's, I think, at the stage we're in, just to look at thought experiments. What if we did this? What would happen? I'm not opposed to study, but to go from study to implementation is a big step.
Well, now, when you were growing up, what made you first decide to become a scientist?
I've always liked how the natural world fit together. I've always been observant of things in the natural world, starting with biology and biological systems. But by the time I was in 6th grade, there was a class assignment, and the answer to that assignment was an equation. It was subtracting two numbers and finding out that they didn't balance a third number, and that piece being important. And I was fascinated that most of the people were answering their questions for this report with 5-page discussions, and I could do it really elegantly with an addition or subtraction equation, and I thought that was really neat. So that's where I kind of left the biology and went into physical science.
Okay. Now, what advice do you have for high school students who may be considering a career in science?
There's all the normal things, which is you should keep taking math, you should keep taking science, you should go to college, you should...
Learn to write, obviously.
Learning to write is very important. I actually have an advantage over a lot of my peers, one, that I'm a native English speaker, and many aren't, but also that I took a lot of English in college. For every math class I took an English class. But I don't know, I just think being yourself and getting a wide variety of experience in a lot of different things is very helpful. You never know what's going to be helpful when you start to work in a job. It's not all sitting at the computer coding. It's not all math. It's not all the physics you learn. Sometimes what you have to do is get on the phone and buy a piece of equipment. You need to know how to negotiate that. You need how to run a budget. You need to write. Artistic work is very helpful in creating the graphics that go into papers. People who have an art, I don't, but people who have an artistic bent are very valuable. And just your life experiences coming into a research group is very, very helpful.
Well-rounded is good.
Well-rounded is always good.
Okay, now you had something that you wanted to demonstrate for us.
Well, one of your
for
questions
students.
was, is there something simple that you can get a whole, demonstrate a physical principle with simple things?
Yes,
Yes.
for young students,
Yes.
or students my age who are
Yes.
just budding scientists.
All right. So I'm an atmospheric scientist, which means that I study the atmosphere. And what is the atmosphere? Huh? It's air. This is just a piece of paper. You can blow it across the table, right? Right? You probably could too. Let's just make sure. I've been playing with it while we talk, so it no longer looks like it once did. Want to go ahead and blow it into the bottle? I'm going to try.
Okay. Oh,
Oh, I was trying to blow it in, but it came out.
this is why science is important.
Yeah, so let's
because
try
the
it.
first several times really fail.
Well, let's try it again. Let's try to blow it in. You want to try again? Get right up to it and try to blow it in. Okay, so why might it not be blowing in? It's an empty bottle, right? There's nothing in it.
Right, right. There's no air pressure in there, is there?
Well, there is air in there,
Right.
so that's the problem.
Oh.
It's full. This empty bottle is full.
Ah.
It's full of air. So you can't blow any more air into it because it's already full.
Interesting.
So the only thing it can do, you increase the pressure inside it and it pushes it out.
Very good.
You like that?
Very good.
Now, if I really, really, really wanted to get that thing inside with only using breath, I would get a straw and I would suck.
No way.
And it would go right.
No way.
Yes, it would. I just didn't have a straw. So
Wow.
that's a nice, easy way of demonstrating that there's a lot. This is not nothing here, where there's plenty of stuff
going
in
on.
this room. We just don't
Interesting.
see. Yeah.
Well, I want to thank you for spending some time with us here and
My
for coming to
pleasure.
Reno for your lecture. We're looking forward to that. We appreciate your efforts and your success.
Thank you very much. It's very nice to be here.
Thank you. You're welcome.